Hello everybody, this is Vasvi from At Home Tuition. So let us continue the lesson Trigonometric functions. Today we are going to talk about the double angle formula. Okay, these are very useful formulae in trigonometry. Actually what it does is it converts the double angle to a single angle. Here say the 2a is converted to sin a cos a, right? 2 sin a cos a. So the double angle is converted to single angle, and sometimes we may use it in reverse. That is, the single angle could be converted to double angle as the case may be. Okay. So here when you learn these formula, you should know that these formula are useful in both ways. Like if you have something like sin 2a, you should be able to represent it as 2 sin a cos a, and if in your problem you get sin 2 sin a cos a, you could replace it with sin 2a also. So quite often these formula are used in the other direction too. So we should be able to move between the two, especially the sine formula. Okay, now let us discuss the formula first and do few problems. Here sin 2a is equal to 2 sin a cos a. I tell you how. You derive this from the formula we have already learned, the addition formula. Sin 2a, I just represent it as sin a plus a. Okay, the 2a I put it this way. So what, as per the sin x plus y formula, it would be like sin a first angle cos second angle, right? Remember we learned the formula, plus sin second angle. Here both the angles are same, so it is again a only, and cos first angle, right? So this is, since both are sin a cos a, I can write it as 2 sin a cos a. Okay, and this is how you have derived at this formula. Okay, now this sin 2a could be represented in terms of tan also. Okay, so that is 2 tan a over 1 plus tan square a is the formula. Next is cos 2a. We do the same like how we did sin a plus a. Same way you can represent this as cos a plus a. Okay, the 2a could be written it as here a plus a, and as per cos x plus y formula, it is cos x. Here it is a only. Cos y, again here it is a, because here your x and y are a, right? Minus sin x times sin y. Here x and y are same, so we write it like this. This is how you got cos 2a as cos square a minus sin square a. Okay, this is understood? Okay. So if you learn it like this, you will never forget the formula. Then this formula could be arrived like the second formula. Cos 2a has too many formulae, like one is cos square a minus sin square a, that we have proved already. Now the next one is 1 minus 2 sin square here a. So what I do is this cos square a, you can represent it in terms of sine. Okay, we have already learned from the algebraic identities. You have trigonometric identities. You have already learned that cos square a plus sin square a equals 1, right? So what is your cos square a? This would be like 1 minus sin square a. Okay, sin square a, and here you already have a sin square a. So these two together, the minus sin square a and minus sin square a, will become minus 2 sin square a. That is how you get 1 minus 2 sin square a. Okay, so this formula is derived like that. And for the 2 cos square a minus 1, instead of converting the cos square a from this cos square a minus sin square a, convert the sin square into cos term. Okay, so what happens, you already have a cos square a here. Just leave it as it is. Now you're going to change. It is minus of the sine square a. I can write it as 1 minus cos square a, right? This implies you have cos square a minus 1. When the minus enters in, it becomes plus cos square a. Got it? And that becomes, this will automatically become 2 cos square a minus 1 here. Now again, like the sine 2a, even the cos 2a could be represented in terms of tan. So the formula is 1 minus tan square x over 1 plus tan square x. Okay. And finally you have tan 2a, which is nothing but sine 2a by cos 2a. So it is 2 tan a over 1 plus tan square a all divided by 1 minus tan square a over 1 plus tan square a, right? The tan 2a is equal to, when you have sine 2a over cos 2a, the denominators get cancelled and you are left with 2 tan a over 1 minus tan square a, okay? And that is how you derive at this formula. So let us see how these are used in the problems, okay? I have taken 3 questions here. Solve each of the following on 0. Okay, so your angle should be somewhere between 0 to 2 pi. Okay, 2 pi is 360 degree. We have to find what x is, what the variable is. Okay, now here they say cos 4x minus 3 cos 2x equals 4. Let me write this as cos 4x. I can represent as, I'm just representing it in terms of cos, okay? So I'm writing 2 cos square x. So here your 2x is 4x. So here the x would be 2x. Got it? 2 cos square 2x minus 1, right? Okay. I'm going to substitute this in the place of cos 4x. Got it? So here, coming back to the question, the cos 4x, I am going to write it as 2 cos square 2x minus 1. Let me continue with this. That is minus 3 cos 2x. Bring the 4 to this side by take away 4 from both sides. So you will have 4 here and on the right side it would become 0, right? 4 take away 4 is 0. Now, let me arrange it, put the like terms together. So this would be 2 cos square 2x minus 3 cos 2x, and this is minus 1 and minus 4 will become minus 5, right? Equals 0. So you can see that this is in some quadratic form, right? To make it easier, let me take the cos 2x as y, okay? So I assume, you can straight away do it, but for convenience sake I'm telling you to take this as y. So this would be like 2y square, because cos 2x is y, minus 3y minus 5 equals 0, right? So factorization here is easier. So this would be, when you factorize this, you would get the quadratic factorization you would have learnt earlier. So I just directly do this. This would be 2y minus 5, and here this would be y plus 1, right? After factorization, let us replace it with the cos 2x. So this would be 2 cos 2x minus cos 2x minus 5, okay, is one factor, and here y is cos 2x, so that is cos 2x plus 1 is another factor, plus 1 equals 0, right? So what will cos 2x be? Therefore, when I equate it to 0, my cos 2x would be, the 5 when it goes to the other side it becomes positive 5 over 2, right? So this is equal to 2.5. So we all know that cos x could not be more than minus 1 to plus 1, right? The range is negative 1 to positive 1. So this is not possible. So this is no solution, okay? You can write no solution for this. Now let me equate the second one. So this is no solution, okay? Or here you have cos 2x is equal to negative 1, right? Taking the 1 to the other side, it is negative 1. So what will the 2x be? It is the place where you get cos as negative 1, right? So your cos 2x is equal to, the 2x could be, the possible values the 2x can take is at pi, right? It becomes negative 1, and at 3 pi, okay, 3 pi you get negative 1. So your x could be, therefore x can be half of this, right? So your x can take up the value pi over 2 or 3 pi over 2. Is that clear? So this is the solution for the first one. So it is simple. You just have to simplify it. Here the next question is sine 2t equals sine t. Okay, you have to solve for this and get the value of t. So sine 2t, we can write it as, we know the formula, right? Sine 2x is equal to 2 sine t cos t, and I just bring the sine t to this side, okay? So what happens, this becomes minus sine t, that's all, equals 0, right? I can take the common term out. The common term here is sine t. I take the sine t out. So what is left here? Here you will have 2 cos t minus 1, right? Equals 0. So you can equate it. Sine t is equal to 0. So when can sine t, what will be the angle? At what all angle is sine 0? You can say that sine is 0 at, so your t should be 0 degrees, okay? Or it can be at 180, right? So that is pi. And you can have it at 360 also. So that I would write it as 2 pi. So these are the possibilities for t here. And now let us take this one. So what happens? It is 2 cos t minus 1 equals 0, right? So you get your cos t as half, 1 over 2, right? So at which angle is cos half? So at 60 degrees, right? So 1 is 60 degrees, so that will be pi over 3, and then when it goes further, yeah, it would be like 5 pi over 3. At these two positions, you can have the t as half. So the values t can take, the angles t can take is 0 degrees or pi or 2 pi or pi over 3, and it can be 5 pi over 3, okay? So this would be the answer for the second question. Let us look at the third one. Here you have sine 2t plus 4 sine t plus 2 cos t equals minus 8. So what I am going to do is bring everything to this side. This would be like, this sine 2t I am expanding and I write it as 2 sine t cos t, okay? Then you have plus 4, I can't do anything to this, so I just write sine t as it is, okay? Then you have plus 2 cos t. I write that also as it is because you can't do anything to this. So and bring the 8 to this side, so that becomes plus 8 equals 0. Okay. Let us take the common term out. I'm just grouping the first two, I put it as a group, and I'm just taking the second two terms, I put it as another group. Here the common term is 2 sine t, right? I can take the 2 sine t out. So what will I be left with? It is cos t, and when 2 sine t is gone, here you will have plus 2. Okay. Plus, here in these two the common term is just 2. So you are left with, I think we have taken the question wrong. This is not 8. This is 4. Okay. We have copied down the question wrong. So this is 4 plus 4. Okay. Now you can take the 2 out. So this would be cos t plus 2 equals 0. Now I can put the ones outside as one factor. So that is 2 sine t plus 2 as one factor, and the other one is cos t plus 2. Okay, equals 0. Equated to 0, what do we get? We get here, you get sine t equals the 2, when it goes that side becomes negative 2 over 2. So that is equal to negative 1, right? So at what time is t negative 1? There is only one possibility. So t is negative 1 at 3 pi by 2, okay? At 270 degrees. Coming to this side, let us do the next one. So you have cos t equals negative 2. So you can't have the value as negative 2 because maximum and minimum would be negative 1 and 1. So this is ruled out. So here it is no solution. Okay. So the only answer you have, the angle you have for t is 3 pi by 2. Hope you all understood this double angle formula and how to use it in the questions. See you with some more problems in the next video. Till then, bye.